Okay, so there are three key rules that you need to know before logarithms will make any sense whatsoever. The first one is called the product rule. And if you remember your rules for exponents, they're very similar. Okay. They're very similar. In fact, they're related. The word product and then the word rule. And to the left of that, right, number one. And then we're gonna create our example, and then we're gonna put in the calculator together. So Hannah W., can you please give me a number between 1 and 5? 4. And Armani, can you please give me a number between 5 and 10? 8. Okay. Oh, I'm sorry. Didn't mean to write it like that. Can you guys write it like this? Write it like that. So this L stands for the word logarithm, and the N stands for the word natural. You say, well, it's kind of backwards, isn't it? Yes, it is. But if we look at the calculator, you'll see why. Down here in the to the left of the 4, the natural logarithm key is ln. So call TI and call the mathematicians of the world and ask them, what gives. But here's what we're going to do. So you got to know what the product rule is before you can put in your calculator. What it says is, whatever this thing natural log is, which we don't really know, but we know it's a button on the calculator, all right? If you hit it, it creates an open parentheses, wants you to stick something in. If you were to stick in 4 times 8, which we will, what it's going to equal is the ln of 4 plus the ln of 8. So here's the key thing to notice. For the product rule, if two numbers are multiplied, you add the logarithms of each component number. So this should start to sink in on a intuitive level for you. Multiplication and addition are always tightly linked, aren't they? With the exponent rules, they're the same way. The product rule, remember, you multiply two bases that are the same and you add the exponents. So that's the product rule. Now let's demonstrate, make sure that math works. So let's go to our calculator, and then we're going to go down here together and press this new key that we're learning. It's always fun. Hit the ln key. And now what we're going to type in is 4 times 8, close parentheses. And then just hit enter. And make sure y'all all get that. It's an infinitely repeating irrational number. Okay? Now, let's type in ln 4, close parentheses, plus ln 8, close parentheses. They're the same. Okay, good? Check how you typed it. Make sure your screen looks just like mine. Okay, so that's as hard as it is. That's the product rule. All right. Now I want to show you something cool. What is 4 times 8? 32. So what if we tried ln of 32? Because somebody asked earlier, well, what if I multiply them together? Let's see. Wow. Pretty cool, right? So the product rule is cool. The product rule is cool, and it's simple, and it's easy, and that's as hard as it is. So now you know the product rule. Yes, ma'am. No. There is a way to do this by hand, but you will not learn how to do that until your 3rd year of calculus in college. So 7 years from now is when you'll learn how to do it by hand. I'll tell you this, that math is so advanced that I don't understand it. Okay? You would have to talk to Miss Wilson or Mr. Shaw. They might be able to tell you about how to do it by hand if you want to see. Okay. So that's the product rule. We were 1 down, 2 to go. Okay? Guys, the quotient rule is just as easy, and ignore that case number from Microsoft. That's obviously irrelevant. Did she? Did she? All right. Let go. I thought she said, anyway, I thought. Yeah, that's right. That's what I thought she said. Is that what you said? Wait a minute. Whoa. You're editing what you said. She didn't say hold on. Yeah. No, you don't say bad words? Somebody give me a measuring stick to measure the nose. Okay. Now let's do the quotient rule, because quotient rule is just as easy as the product rule. Hello, Jimena. Can I please ask you for a number between 1 and 5?
7.
Let me just ignore all of that because I was asking Jimena. Yeah. 3. Okay. Now, Tyler, can you please tell me a number between 5 and 10? 9. Ooh, I like this one. Okay. So here's what we're going to do. Now put that in parentheses and put an ln in front of it. So the way you say what you're seeing on the screen is the natural logarithm of 9/3. Okay? Or 9 divided by 3. So here's what the rule is, just so you know, because some of y'all are pressing buttons and you don't know the rule yet. So I bet one of you could guess the rule. It is the direct opposite of the product rule. What do you think you do? Subtract. Yeah. So that would be ln of 9 minus ln of 3. You thought that was what it was? Good. You have that intuition now. Okay. So let's go to the calculator and type in, it's okay. Just type it in, ln, and then watch this carefully. Everyone needs to look up and watch this. To put a fraction in, you hit alpha y equals, enter. Nine over 3, and then you need to hit the right arrow, or else you'll put a little tiny close parentheses in the denominator. You want to put a big old close parenthesis right there. Now hit enter. And we don't really care about this number. We want to see if it's the same when we do ln of 9 minus ln of 3. They're the same. Now, what is 9 divided by 3? 3. So just check ln of 3 and see if it's the same. So just confirming that you can go ahead and do the internal division or multiplication and save yourself a little time. Where this becomes a little bit more complicated is when the fraction contains letters. All right. Yep. Then what would you do? What if there was more than one letter? What if, like, it was X 2x over 3y, then you would have, thank you. You can't put the y into the graphing calculator. Thank you, sir. All right. You can put the x in, but you can't put the y in. No. Yeah. These calculators will only accept one variable, x. You mean like a TI 92 and stuff like that? They're just more advanced. The least advanced is no. They go way down to like little $5 calculators. Let's not lose the plot. So now we got 2 down, 2 of 3. Y'all are doing great. Now we're gonna skip the reciprocal rule for now, and we're gonna do the power rule. Lexi, can you please give me a number between 5 and 10? Cool. Now, Nathaniel, could you please give me a number between 1 and 5? Okay. Now, y'all write ln, open parentheses, close parentheses. Make sure you get it around that whole thing. Now, don't type it yet because this is different. The power rule is the only one that you're going to have to do something before you put it in the calculator. Yeah. I'm sorry. What did he say? Well, I'm saying like I'm only teaching you 3 rules right now. There are 4 key rules, but we're going to skip the reciprocal rule, so you can call it 3 or 4, whatever. You can put reciprocal rule and then skip a line. I don't care. Now, let me show you guys how to do this so I can start getting you going on your homework, okay? No, this is different, okay? So that 2 in the exponent section has to come down and live right here. Hold on. It is multiplied by ln, and you moved it, okay? You moved it. So it's not there anymore. It's gone, and it lives down here. So I want to show you again, because this was a 2. You pull it down in front of 5. Okay? Right. So I'm going to write the whole thing out. Hang on. ln of 5 squared is equal to 2 ln of 5. Okay, and 2 ln of 5 is the same as 2 times ln of 5. Your calculator will automatically multiply it whether or not you actually hit the times sign. So let's go check and make sure this works. ln of 5 squared is 3.21. So we just put it in like we was given to us. Now let's do 2 times ln of 5 and see if we get the same number. Now there's a couple of special. So now you understand the power rule. Okay. Now there's a couple of weird cases, and I actually only want you to focus on these that I highlight here. And we're going to learn them. We're going to learn them in a special way, okay? Forget about writing them. I want you to watch, do it on your calculator. Prove it to yourself. Type in ln of 0 and see what it does. Uh-oh. Error. Domain error. Okay? X error. Something's wrong with it, okay? So let's go back. That's good because the rule is that the natural logarithm of 0 is undefined. Yes. Here's my thoughts on it. Any time in your life that this comes up, you will either be given this chart or you can just Google it. So yes, write it down, but remember this. Remember how to figure it out on your, like, if you don't try to memorize, okay, ln of 0 undefined, flashcard, ln 0 back, undefined. Just, if you ever forget, go type it in to the calculator. And look, guys, I want to show you something neat, because I know you guys are writing, so don't freak out on me. Just hang on. If you go to google.com, look at this. Type in ln, open parentheses, 0. Do you see that? Look. Now, Google is going to function just like a graphing calculator. Uh-oh, it's not doing this one. Wait a minute. Let me see it. Hang on. I want to see. I thought Google would do it. Well, now I learned something. Google, because Google will do almost all calculations, but on this live stream, we just proved that Google isn't all that it's cracked up to be. Okay. I was going to try to, let me go to Desmos and see if this, what Desmos does when we plug ln 0 in here. So y equals ln of 0. Ooh, look at that. Okay, it tells you. In other words, it tells you. Okay, it tells you. So if you forget the rule, it will tell you the rule. Now, how about ln of 1? Let's prove to ourselves that the natural log of 1 is 0. Yep, it's 0. Okay, so let me ask a question over there. How old are you? So if I multiply your age by the natural logarithm of 1, what is the answer? 0, because the natural logarithm of 1 is equal to 0. So every time you see natural log of 1, you think 0, and you'll avoid the pitfalls, okay? But you just plug it into your calculator, it'll do it for you. Now, let's do this one. ln of e. So, ladies, I'd love to teach you how to do the natural log of the transcendental number e. Hang on. Let me show you where you can get this letter. Do you see this, the division key? That is this special, it's different, okay? It's different than the green E. The green E right here is literally just the alphabetic letter E. It has nothing to do with math. This special letter is going to look different when you type it. So to get the blue letters, you have to hit the second key. Okay, and then type E. And if you just type E all by itself and you hit enter, it's going to give you the approximate value of this number. So this is a very special number. In fact, that's why they actually put it on the calculator. It is even more, well, equally as special as pi. Okay, so if you can remember 2.71, it's going to help you in your life. Like you all know 3.14 pi. And now you need to learn that 2.71 is E, okay? Or 2.72 if you want to round up. Now, let's do ln of E. So natural log of E is equal to 1. That's very interesting. You want to try ln of the actual, so look how I'm going to grab this. ln, and then I'll hit up, 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 and grab it. Yeah. Good, that's good. That's nice. Yeah, because this would go on for infinity and never repeat. Yeah. Do you guys know how to change the float on your calculator? Okay. Hit mode. You can go change the float out to, go change it to 9. Okay. And then go back home. And now hit this E again, second division symbol. Oh, I see. I already have my second quit. Second mode will get you back home. Well, if your calculators were already set to have a float of 9, then it's just going to look the same. But you can change the float on your calculator. Like if you wanted to change it to 1, you could do that, and then you could go home, and then you could go get that E again, and it's only going to show 1 decimal place. Okay. You don't have, no, because if you want to have the calculator float set out as far as possible. Otherwise, it's going to do something weird with the rounding. All right. Yeah. Yeah, it should be auto set to default to that. Now, guess what? You've learned the 3 rules, and now I want to show you how to actually do logarithm problems, okay? So this is actually solving logarithms. Let me show you a couple of these. We'll do this one first. These are from Paul's notes. Dr. Paul Dawkins. So let's take this one and solve it. He was my calculus and teacher in at Lamar University in Beaumont back in 2002, ladies and gentlemen. Were any of you born? Did she really? Okay, let's do this little example problem. Ignore all this other stuff. Just, all right. Actually, if I move it over a little bit, I can literally get it off screen. There we go. Hey, this is easy, okay? So what we're going to do is you're going to rewrite the problem like this. Ln, and then just put 5 to the 3x like this. Equals Ln to the 5 to the 7x minus 2. Okay? Now don't go plug it in the calculator because calculator isn't going to tell you anything. Because there's an x in there, it's going to be screwed up looking. Hold up. We're going to apply the product rule. Watch, you're going to like this. Y'all are going to think this is neat. So just go with me. Remember, this homeboy, he's going to come sit here. Okay? And then it'll be gone up there. And then the same thing's going to happen with this. You're going to move this whole expression right here, and then it'll be gone. Okay? So let me rewrite how I want you to write it. What you should have on your next line is 3x times ln of 5 equals, open parentheses, 7x minus 2, close parentheses. That's that whole thing from the exponent, times, you can finish, Michael. You know what to say. Mm-hmm. 5. Now, wait, we're not done. This is going to become really, really cool in just a second, all right? Now, right now, it looks scary and complicated. But notice that on both sides of the equation, I have an ln of 5. That means I can cancel it out. So watch this. You go divide both sides of the equation by the ln of 5. Yes, sir. Oh, all right. Okay, now look at this. Y'all watch. Here it comes. This is the magic happening. We're going to cancel out all the ln 5s that we see. They're gone now. Okay? Now you just write 3x. No. 3x equals 7x minus 2. We're not going to put it in. We're not done. You want to say it, Kimberly? I'm going to subtract 7x to both sides. Oops. Okay, so now I've got negative 4x. And over here it canceled. And this equals negative 2. Because this guy comes down here. Now divide both sides by negative 4. Close. You get positive 2 over 4, which can be reduced down to 1/2. Okay, so let me, this is, you've learned a trick. All right. This is a trick, and it only works when both numbers, we call these big numbers here bases. Okay. Do you see? The bases are the same. Y'all label these numbers bases. Okay. These are called bases, like in a game, a softball game or baseball game. When the bases are the same, you can just drop them and set the exponents equal to one another and solve the equation. So you can skip all that stuff that we did, all this stuff about dividing ln of 5 by ln of 5. The trick is, if the bases are the same, you can just drop the bases and set the exponents equal to one another. That seems like magic to me. So let's see if it really works. Let's do another one. Let's do 3. Let's do no. Let's do 4 to the t squared equals 4 to the 6 minus t. Hang on, let me just get somewhere where I can write it. What was it? 4 to the t squared.
Pardon this interruption. There is no ag mechanics going on this afternoon. So, us or ride or walk home.
Okay, now check this out, guys. So the bases are the same, and as a result, I can just drop them entirely and set my exponents equal to one another. T squared equals 6 minus t. Now, do you want to? Okay, we want to rewrite it with x. We have a request to switch to x. So let's do x squared equals 6 minus x. Now, what I want to do is get this in standard form of a quadratic. So I'm going to add x to both sides and subtract 6 to both sides all at once. Minus 6 plus x. These cancel, and there's a 0. And now you've got x squared plus x. No, we want to keep it in standard form. Minus 6. This is what it needs to look like. And now we're going to factor and solve this quadratic. It's too easy to put in the calculator. All you need to tell me are two numbers that add to equal 1 and multiply to equal negative 6. Now, which one is negative and which one's positive? The 2 is negative. So here's how you write that, guys. Negative 2, positive 3. Negative 2, positive 3. So now we do this. X minus 2, x plus 3. Set the factors equal to 0. And then solve for x 2 times. Oops. So if someone said, what was the answer to that question? You'd say, well, the answers, plural. Yeah, if you wanted to write it in the correct notation, you would do it in least to greatest like this, negative 3, 2. We're done for the day. You did it. Now, I'll just show you before y'all start getting going, your Delta Math homework, exponent rules. Let's take a look at that assignment so you see. Each one of these skills has 2 questions. They're easy. Now, here's one example of one. Look. Just look, watch. And you'll get it. Y'all are doing super good today. This makes me proud. So look, You already know how to do these problems. Look, just watch. We're going to distribute the 3 exponent to these 2 exponents here. Okay? We're just simplifying this. There's nothing to solve. So now I have 3 to the 3rd power times u to the 4 times 3, which is 12, all over 4 times u to the 10th power. And so here's what I recommend. I recommend just splitting this up and worrying about this as a separate issue from this. All right? Because they don't mix. So now we just write, what's 3 to the 3rd power? Anybody know? Nine times 3? It's 27. So we have 27 over 4 as a fraction. Just forget about that. Now the quotient rule means that you take the exponents and you subtract them. So it's u to the 12 minus 10. What's that? 12 minus 10 is? So this is the answer. Or however, maybe he wants you to write it 27u squared over 4. Whatever. It's the same thing. Not hard. So that's the homework that you start tonight. And then if you have time, or if we have time on the other one, we could start solving exponentials. So thank you guys so much. And let me end the live stream here. It was a great class. Have a great day and see you on the live stream tonight.